Ever wondered how computers make sense of massive amounts of data? Today, we're going to peek behind the curtain and explore a secret weapon used by data scientists and ML engineers, linear algebra. So, in this video, we'll explore the fundamental concepts of linear algebra that are essential for understanding and solving problems in statistics. We'll start by discussing what linear algebra is and why it's important in data science. Next, we'll delve into solving linear systems of equations, which are equations involving multiple variables. You'll see how we can find solutions to these systems using simple methods. Then, we'll move on to matrices. You'll learn what a matrix is, the different forms it can take, and how we can perform various operations on matrices, such as addition, subtraction, and multiplication. These operations are crucial for many statistical computations. Finally, we'll talk about vectors. Vectors are like lists of numbers, and they have specific properties that make them useful in many areas of data science. By the end of this video, you'll have a solid grasp of the key concepts in linear algebra and be ready to apply them to your data science projects.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
Learning objectives. Welcome to Math Refresher, Linear Algebra. In this lesson, we are going to explain the concepts of linear algebra, solve a linear system of equations, describe matrix, forms of matrix and matrix operations, and define vectors and list down its properties. Introduction to linear algebra. Linear algebra. Linear algebra refers to study of linear combinations. For linear transformations to be carried out, a study of vector spaces, lines, and planes, as well as some mappings is necessary. It contains linear functions, vectors, and matrices. It is an examination of characteristic of linear set transformations. Linear equations. Linear algebra's major goal is to establish systematic techniques for solving systems of linear equations. A linear equation with n variables can be represented as a1x1 plus a2x2 plus a3x3 and so on till an xn equals to b, where x1, x2, x3 and so on till xn are the unknown quantities that are to be found, while a1, a2, a3 and so on until an are the coefficients. B here is a constant term. A linear equation with two variables, x and y, is a linear connection between x and y. The value of one variable, often y, is determined by the value of the other, that is x. The independent variable in this situation is x, while the term dependent variable refers to y. Since it depends on x, let's consider some examples for linear equations. Linear equations in one variable can be written as 3x plus 5 equals 0, or 3 by 2 of x plus 7 equals to 0, or 98x equals to 49. Linear equations in two variables. Examples can include y plus 7x equals to 3, or 3a plus 2b equals to 5, 6x plus 9, y minus 12 equals to 0. Linear equations can also be written with three variables as x plus y plus z equals to 0, a minus 3b equals to c, 3x plus 12y equals to half of z. Identifying linear and nonlinear equations. Linear equations present themselves as a straight line on a graph. However, nonlinear equations represent themselves as a non-straight line on the graph. Here, equations like y equals to 8x minus 9 or y plus 3x minus 1 equals to 0 are examples of linear equations. However, y equals to x squared minus 7 is a nonlinear equation because x is raised to the power 2. Hence, denoting a nonlinear relationship or a non-straight line relationship between x and y. Similarly, square root of y plus x equals to 6 or y raised to the power 2 minus x equals to 9 are examples of nonlinear equations, as y is raised to the power half and 2 respectively. Forms of linear equation. Linear equations can be represented in three forms: a standard form, a slope-intercept form, or a point-slope form. Linear equation in standard form. A linear equation in standard form for a single variable can be represented as a x plus b equals to 0, where a and b are real integers and x is the variable, while a linear equation in standard form for two variable can be represented as ax plus by equals 2c, where a, b, and c are real integers, while x and y are the variables. To summarize, a linear equation for variables can be written as ax plus by equals to c, where x and y are the variables. C is the constant and a and b are the coefficients of x and y respectively. Linear equation in the slope-intercept form. A linear equation slope can be calculated to see how one variable varies in response to a unit change in another variable. It is represented as y equals to mx plus b, where m is the slope, b is the intercept on the y-axis and x, and y are the line's distance from the x and the y-axis respectively. Consider this example. The line's point x, y represents the distance from the x and the y-axis respectively, while the line intercept on the y-axis is at point 0, b. Linear equation slope. The slope indicates how steep a line is with respect to y-axis. When seen from left to right, it indicates whether the line goes up or down. The slope describes how independent variable has been changed, while the dependent variable is changing. Types of slope. There are four types of slopes based on the relationship between the two variables x and y. The first is the positive slope here as x increases. Y is also increasing in a negative slope as x increases. Y decreases. If a line is parallel to x-axis, it is a zero slope. On the other hand, if the line is parallel to y-axis, then the slope is undefined. Linear equation in point-slope form. A straight line is represented in point-slope form by its slope and a point on the line. It is represented as y minus y1 equals to m of x minus x1, where x1 and y1 are the coordinates of the point. Linear equation forms, some examples. Consider solving the linear equation given as 2x minus 10 divided by 2 equals to 3x minus 1. First, we will clear the fraction. In this example, we can see only left-hand side we have 2x minus 10 divided by 2. If from the numerator we take 2 as common, we will be left with 2 times x minus 5 divided by 2, hence x minus 5 on the left-hand side. On the right-hand side, we still have 3 times x minus 1. Now, as a part of next step, we simplify both sides of the equation, that is, open up the brackets. When we do that on the right side, we end up getting 3x minus 3 by multiplying 3 to x minus 1. Solving further, we can write as x equals to 3x plus 2. Finally, we try to clear the fraction to solve for x. We can rearrange the equation as x minus 3x equals to 2. Solving it further, we get minus 2x equals to 2. And then we solve for x as minus 1. System of linear equation. A system of linear equations is a finite collection of linear equations, usually involving the same variables. It can be represented as a11x1 plus a12x2, and so on equals to b1, a21x1 plus a22x2, so on equals to b2, and so on. Here this example is for n variables. A system of m equations. A linear system can have unlimited number of solutions, one solution or no solution at all. In case of a single linear equation, a consistent linear system has a solution, while an inconsistent linear system has no solution. Solving a linear equation. Solving linear system of equations. Various methods can be used to solve linear system of equations, which include graphic method, substitution method, linear combination or elimination method, or a matrix method. Graphing method. Let's try and solve these two linear equations using the graphic method. The first equation is defined as y equals 0.5x plus 2, and the second equation is y equals to minus 2x minus 3. The two equations, as we can see, are in the slope-intercept form. The first line has a slope of 0.5 and a y-intercept of positive 2, while the second line has a slope of negative 2 and a y-intercept of negative 3. Let's have a look at these lines through a plot. Here, the blue line is the first line represented by y equals 2.5x plus 2. And the red line is represented by y equals to negative 2x negative 3. These two lines intersect at a point at negative 2, 1. Hence we can say that x equals to negative 2 and y equals to 1. Solving systems of linear equation using substitution. For substitution, we start by putting one of the equations in the form of variable equals to. We then substitute that variable in the other equation in its place. Take the other equation to solve. If there are more than two variables involved, we repeat the process from steps 1 through 3. Let's consider an example. Let's consider the equation 3x plus 2, y equals to 19 and x plus y equals to 8. We could begin with any equation and variable. In this case, let's look at the second equation with variable y. We start with subtracting x from both sides of x plus y equals to 8. And we end up getting y equals to 8 minus x. The first equation still retains its form. Now we take the value of y, that is 8 minus x, and substitute in the first equation in place of y. We end up getting the equation 3x plus 2 times 8 minus x equals to 19. We further simplify and solve this equation using algebra method to get 3x plus 16 minus 2x equals 290. We solve this equation further, and we end up getting x plus 16 equals to 19, and finally x equals to 3. Now we take the value of x and substitute in the new reformed second equation as y equals to 8 minus x. That gives us y equals to 8 minus 3, hence y equals to 5. The final answer remains x equals to 3 and y equals to 5. Solving systems of linear equation using elimination. In this case, we start by multiplying an equation by a constant anything other than 0. We then add or subtract an equation onto the other equation. Let's consider the same example of 3x plus 2, y equals to 19 and x plus y equals 8. We first start by multiplying the second equation by 2, and we get 2x plus 2, y equals 216. Now we subtract the second equation from the first equation. That is 3x minus 2x, 2y minus 2y, and 19 minus 60. On solving this, we end up getting x equals to 3. Now, using these steps of substitution, we put the value of x in the original second equation, that is x plus y equals to 8, and achieve a value of y equals to 5. Hence, the answer remains x equals to 3 and y equals to 5. We can verify the solution by using the graph. Here again, the blue line represents the point at which 3x plus 2, y equals to 19 is true, while the red line represents the point where x plus y equals to 8 is true. The solution is found at the point where x equals to 3 and y equals to 5. This is the point where both lines intersect. Introduction to matrices. Matrix. A matrix is a rectangular array or table with rows and columns of numbers, symbols, expressions used to represent a mathematical object or an attribute. For example, here A is a matrix of 2 rows and 3 columns, as 2, 1, 3, minus 1, 2, and 4. Well, B is a squared matrix with 2 rows and 2 columns given as 2, 1, 3, 4. Matrix size. The matrix size is expressed as m cross n, where m is the number of rows, and n is the number of columns. A matrix with 2 rows and 3 columns can be referred to as 2 by 3 matrix, or a 2 cross 3 matrix, or a matrix of dimension 2 cross 3. Notation of a matrix. A matrix with m rows and n columns can be presented as this. Here, each element will be identified by its row number and column number. For example, the element over here is in the 3rd row and the 1st column. Hence, it is identified as a 3-1. Forms of matrix. The matrix is termed as a squared matrix. If n equals to m, that is, the number of rows and number of columns are equal. An element's entry in the matrix of from A, I is located on the diagonal. A is called a diagonal matrix if A ij equals to 0, when I is not equals to j, that is in a square matrix. Apart from diagonal at all places, we have 0 as a value. Matrix operations. Addition. Addition of 2 matrices is adding their corresponding elements, as in A11 plus B11, A12 plus B12, A21 plus B21, A22 plus B22, and so on. Consider the example over here. We have a matrix A as 22, 32, 11, 16, and matrix B as 13, 8, 13, and 16. Matrix A is of the order 2 cross 2, and matrix B is also of the same order, 2 cross 2. Hence, the corresponding elements can be quickly added as 22 plus 13, 32 plus 8, 11 plus 13, and 16 plus 16, giving us the result in matrix of 35, 40, 24, and 32. Addition rules. Only matrices with the same size can be added. That is, the 2 matrices should have same number of rows and same number of columns. Matrix addition follows commutative property. That means A plus B is equals to B plus A. Subtraction. Matrix subtraction is same as matrix addition. It is subtracting the corresponding values. Let's consider the same example of matrix A and B. The result of A minus B can be given as 22 minus 13. That is A11 minus B11. 32 minus 8. That is A12 minus B12. 11 minus 13. A21 minus B21. And 16 minus 16. That is A22 minus B22. Giving us result as 9, 24, -2, and 0. Subtraction rules. Only matrices with the same number of rows and columns can be subtracted. Matrix subtraction does not follow commutative property. That means A minus B is not equals to B minus A. Multiplication. Matrix multiplication results in what is called as a product matrix. In matrix multiplication, each row of the first matrix is multiplied to each column of the second matrix. To compute each of these elements in the matrix, the values are then added. For example, consider the matrix A and B. To get the first element, we will multiply the first row of matrix A to the first column of matrix B, and then add the individual elements, that is 22, multiplied to 13, and 32 multiplied to 13, and then add them up to get this particular element. For the second element, we multiply the first row of A to the second column of B, hence getting 22 multiplied to 8 plus 32 multiplied to 16. Similarly, we compute all the remaining elements, that is the second row multiplied to the first column, and added 11 multiplied to 13 plus 16 multiplied to 13, and the second row now multiplied to the second column, that is 11 multiplied to 8 plus 16 multiplied to 16. This gives us the resulting matrix as 702, 688, 351, and 344. Multiplication rules. Let us say C equals to AB. Here, C is our product matrix, which can be computed as summation over A at ij dot bjk. For a matrix of size ij, matrix B of size jk, to calculate the value of each member in the I cross K matrix of C. The matrix product AB is defined only when the number of columns in A equals to the number of rows in B. The matrix product of BA is defined only when the number of columns in B is equals to the number of rows in A dot B is not always equals to B dot A. Transpose. A transpose is a matrix form by turning all the rows of a given matrix into the columns and vice versa. The transpose of a matrix A is denoted as AT. For example, if the matrix A is 22, 32, 11, and 16, the transpose of A would be 22, 11, 32, and 16. Here we can see the row has been converted to column. Inverse. If it is a non-singular square matrix, there exists n cross n matrix, a minus one known as A's inverse, that satisfies A dot A inverse equals to A inverse dot A equals to I, where I is the identity matrix. And identity matrix is characterized as a diagonals 1 and all other elements are 0. Also, AB equals to B dot A equals to IN, where IN denotes the n cross n identity matrix. Special matrix types. Symmetric matrix. A matrix A is set to be symmetric if A is equals to transpose of A. Diagonal matrix. A matrix D is diagonal only if Dij equals to 0, for all I not equals to j. Identity matrix. Identity matrix is denoted as IN where AIN equals to IN dot A equals to A. Tensors. Tensors are arrays with more than two axes. A tensor can have n dimensions. Aijk is the value in the tensor A at coordinates ij and k. The principal component analysis PCA, which is a statistical technique used to reduce the number of dimensions in a given data set while we preserve its variability. So there are different use cases of PCA in real-time scenarios. One of the major use cases is in the healthcare domain, so technically known as the spike-triggered covariance analysis. It uses the principle of PCA in neuroscience to identify the specific properties of a stimulus that increase a neuron's probability of generating an action potential. So it is using reduction techniques, which is going to be really helpful in detecting the coordinated activities of large neuronal ensembles. So it is basically used for identifying a neuron from the shape of its action potential. Then in terms of quantitative finance. So PCA help us in reducing the dimensionality of a complex problem. Let's say a fund manager has 200 stocks in his portfolio. Now to analyze these stocks quantitatively, a stock manager will require a correlational metric of a size 200 by 200, which makes the problem very complex. However, if he has to extract 10 principal components, which best represents the variance in the stock price, this will reduce the complexity of the problem while still explaining the movement of all 200 stocks. So we use it for analyzing the shape of the yield curve in terms of forecasting the portfolio returns, developing the asset allocation algorithms, and so on. And it is also widely used in image compression. So PCA is also used for image compression. So if we go ahead and use any of the PyCharm IDE, so here we can work with Matplotlib, ImagePyPlot, and the NumPy as NP. And here we can also import from sklearn. And we can import the PCA. So basically we are trying to print the shape of the image by reading the image. This is a sample logo.png, which has been placed in the same directory. We are trying to print the image. So if we run this particular code, then we will be able to see the shape of the image. Return to us first the current shape based on the image which has been deducted, which is 156, 94, and 3. So what does this mean? This means image is in the form of 156 rows, and each row containing 194 pixels, and then having 3 channels, which is red, green, and blue. So we had to resize the image so that it is in a format required for PCA input, which is 196 by 3, which is going to be 582. So here we can see we have performed a simple operation as image_r, where we are using the NumPy library for reshaping the image. And then we are printing the shape of the image again. So here we can see 156 and 582 has been returned as a response. Now running the PCA with 32 principal components, we can use this fit for the image that has been reshaped, and then we are trying to train the transform image. So with these 32 components, we are able to express 98.7% of the variance. So inverse transforming the PC output and reshaping the visualization can also be done forward. And that's how PCA is widely used as a part of the medical and the other sciences. For example, is used for object detection model for the healthcare domain for the transportation, aviation, and location-based services. Introduction to vectors. Objects with both magnitude and direction are called as vectors. The magnitude of the vector determines its size. It is represented as a line with an arrow, where the length of the line indicates the vector's magnitude, and the arrow points in the desired direction. Other names for it include Euclidean vector, geometric vector, spatial vector, or simply vector. Its length is indicated by the symbol double bar v double bar, and it begins at the original 0, 0. Notation of a vector. A vector can be represented in a standard form as A equals to AI cap plus BJ cap plus CK cap, where A, B, and C are numeric values. The unit vectors along the x, y, z axes are I, j, and k cap respectively.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.